Okay, today's video is a review of Module 2A Semester 1. First thing to note is what's in blue and gray here. So discrete is something that's countable with unconnected dots. Continuous is connected dots and it's measurable situations. Linear are straight lines and it's when we have adding or subtracting. Exponential is when we multiply or divide. Those lines are curved, but what's more important too is remembering that percents are part of exponential. So looking at this first graph here, we have an exponential because it's curved, and it's continuous because it's connected. Next up, this graph is linear because it's straight, and it's discrete because they're unconnected dots. Next up, we have rounds 1, 2, 3, 4, 5. Number of players 64, 32, 16, 8, and 4. That is going to be exponential because we're dividing by 2. But remember, with exponential, we can't use division, so we have to multiply by 1/2. And it's discrete because we're talking about people. You count people, you don't measure people. 4, we have months 1, 2, 3, 4, 5, and then tomato height 5, 7, 9, 11, and 13. Tomato height is linear because we're adding by 2, right? And then it's continuous, right? Because we're talking about growth. You can measure growth. Next up, we have to figure out if this is linear, exponential, or discrete. Well, it's going to be neither. Reason being is first we add 2, then we subtract 1, and then we subtract 3. We've never done that, so no, which means we do not care if it's discrete or continuous. Same thing with number 6. This is going to be neither. We've never seen a graph like this before, and we don't care if it's discrete or continuous, although this one would be continuous. Number 7, this is exponential, right? 2 ways you know is because you're multiplying by 5 and you have an exponent. And then this is going to be continuous because we're given an explicit equation. Anytime you're given a straight explicit with no background information, assume it's continuous. Versus number 8 here, well, this in number 8 is linear, right? Because we're adding by 3, but we're going to say it's discrete. And whenever we see a recursive, which is what this equation is, with no background information, assume it is discrete. So the next one is exponential because we're timesing by 3, and then it's discrete because it's recursive. The next one is linear because we are adding by 4, and it's continuous because it's exponential. And yes, it is adding by 4 because remember, the number with the x is the number we add by as we go down our table. In the next one here, 11 through 14, we're going to figure out if the scenarios are linear, exponential, discrete, continuous, increase, decrease, and then draw a basic graph. So Miss McDonald started growing a Christmas tree that doubles in size every month. Well, if it doubles, that's exponential. It means our graph is going to curve. We're growing a tree, so that's a continuous thing, so it's going to be connected. And if we're growing a tree, that's an increase, so that means it's going to go up. So when I draw a super basic graph about this, it should be curved, going up, and then I connect the dots. That's it. No numbers, no nothing. Can you tell how to do it? 12, Ms. Bravo has 400 mechanical pencils. She will give away to 5 students each day. So that's a linear thing, which means it's going to be a straight lined graph. It's a discrete thing because you count pencils, so that means it's unconnected. And then it's a decrease because I'm giving them away, so that means it goes down. So, graph here, it's going down, it's a straight line, unconnected. 13, Mr. Poskis' dragon he rides to school breaks from 100 miles per hour and he loses speed at a rate of 30%. 30% means it's exponential, so it curves. It's continuous because it's about speed, so it's connected dots. And it's a decrease because we're slowing down, so it's going down. So curved, going down, and the dots are connected. Ooh, bad connection there. 14, Miss Woods and Miss Jascuna started with $40 saved for the end of the year bath pizza party, and at the end of each month they saved $10 more. So this is linear because they're saving $10 more, so that's going to be straight. It's going to be discrete, and the reason why it's discrete, it says at the end of each month. So not during the month, not from the start to the very end, but just straight up at the end of the month. So that's how you know it's discrete. So this is going to be unconnected. And then it's going to be an increase because they're saving money, so it's going up. So here we go. Straight line going up, unconnected dots. Bada boom. Next up, we're going to write equivalent expressions using x's and y. So I'm going to use some colors here. So what I want to write first is my term with the variable. So that 4n changes to a 4x, and it stays positive here. This 3 is still positive, so I write plus 3. This is more of a linear formation, the colorful 4x plus 3, versus f of n, that's more arithmetic. So the next one, our 9n goes first, so it changes from 9n to 9x. It stayed positive. And then this -2 becomes -2. Same thing. Good. Next up, we have that -5n becomes a -5x. And then that 7 is positive, so I show that it's still positive. Next up, we have -5n, so we have -5x. And then -1 stays -1. We're going to distribute, so remember parentheses mean multiply. So first we're going to multiply 2 into the parentheses, so that's 2x, and it stays positive. And then we have 2 times -1, which is a -2. Nothing else changes, so we keep it all the same. Then we combine like terms, 4 minus 2, which leaves us with 2. So our final answer is y is equal to 2 plus 2x. Or you can write it as y equals 2x plus 2. They mean the same thing. Just know that they are the same because you might solve it one way, but you may solve it, for example, this way, but on your final, it'll look like this. So make sure you know that these are equal to each other. All right, next up we have -3, so we're going to take that -3 and multiply it, so -3 times x, and then we got -3 times -4, which is a positive 12, and nothing else changed, so we bring everything else down, and then we combine like terms, which is 12 and 3, so that's 15. Nothing else was messed with, so here's our final answer. Now remember, it could also look like 15 minus 3x. Notice how that 15 is still positive and that -3x is still negative and still has the x. All right, next up we have -2, so -2 times x is a -2x. Then we have -2 times 5, which is a -10. Nothing else changed, so we bring everything else down. Combine like terms in this case is -4 and -10, which is a -14. Nothing else was messed with, so we have y equals -14 minus 2x. Or it could also look like -2x minus 14. Very good. 22, we have 5x. And then we have 5 times 6, which is plus 30. Nothing else changes, so we bring down that -7 and the y equals. Combine like terms, which gives us 23. So we get y equals 5x plus 23. Or it can look like y equals 23 plus 5x. They mean the same thing. All right, now we're going to do these last 3. So Miss Rouse wanted to grow her fir tree for Christmas. When she planted the tree on the first day, it was 20 inches tall. Each day after, the tree grew 8 more inches. So on the first day, it was 20 inches tall. Each day after, it grew 8 more inches. So that means I'm adding by 8. So when I go down my table here, these are the numbers we get. When we write the explicit, we can write it as y equals 20 plus 8 times x minus 1, regular size. We start with a time 1. Or it can look like y equals 8 times x minus 1 plus 20. Okay, both are good. See how this stayed together and then that 20 stays positive? They mean the same thing. This is continuous because we're growing something, so it's going to be connected. And then it's linear because we're adding, so that means it's going to be straight. So when we graph this, we started with 1 and 20, so start with 1 and 20. Then we have 2 and 28, so we have 2 and 28, it's about right here. Then we have 3 and 36, so that's about right here. And then we have 4 and 44, so that's about right here. And look at that, it's a straight line. I got it connected. Here we go. Amazing. Now, how tall will the tree be after 30 days? Well, 30 days is our x's, right? So let's reuse that explicit we wrote for letter B, I believe. Yeah, B. So our explicit was y equals 20 plus 8 times x minus 1. So we're replacing this x with a 30. So nothing else around it should change, right? Everything else should remain the same. Now, you can do this two different ways. You can use your distributing stuffs, right? So 8 times 30 is 240 minus 8. And then we bring down that 20. And then some kids did 20 plus 240, so that gives us y equals 260 minus 8. And 260 minus 8 is 252. And that's your final answer, and that's good. All right, 24, Miss Jaskunis thought a Christmas tree would look great in her classroom. She plants the tree on the first day when it is 5 inches tall, and each day it growth doubles due to her Zen calmness. So on the first day, it's 5 inches tall, and then it doubles every day. So every day it doubles, so that means I'm timesing by 2, so we got 10, 20, 40. So when I write my explicit equation, I got y equals, well, we started with 5, we're timesing by 2, and this is going to have an exponent, x minus 1, because we started at time 1. This is continuous because it's a tree, it's exponential because we're multiplying, so when we graph it, it should be connected and curved. So 1 and 5 is going to be about right here. Then we have 2 and 10 from our table, so 2 and 10. And then from our table, we have 3 and 20, so 3 and 20. And then we have 4 and 40. Now, it kind of looks like it's going up, but let's think about this. After 4 and 40 would be 5 and 80. And this is where you really start to see the curve happen. Now, in letter F, it says, how many will it be after 11 days? Now, we can plug it in like we did in the last problem for letter F, but I'm sure many of you would prefer to do something more like this, right? So we had day 4, 5, 6, 7, 8, 9, 10, 11. So now we double. We got 80, then we got 160, then we got 320, then we got 640, and then we got 1,280, and then we have 2,560, and then we have 5,120. So that's our final answer, is 5,120. I just kept multiplying by 2. All right, Pascus, Mr. Pascus wants to have all the classrooms to have an elf on the shelf hidden. He decides to pull a move like the Grinch and does it all in one night right before finals. The school has 350 rooms that don't have an elf on the shelf. Mr. Pascus is able to put an elf into 25 rooms every hour. So, looking at this, the school has 350 rooms. No hours have passed. We're just told that it has 350 rooms, so that's going to be 0 and 350. Because, look at the wording here. Rooms without an elf on the shelf. Now, if he's putting an elf into 25 rooms every hour, that means there are 25 less rooms with an elf, or that are empty. So when I fill out my table here, I got 325, I got 300, and then we got 275. So when we write the explicit, we got y equals 350 minus 25, and then just an x, because we start at time 0. You could also write this as y equals minus 25x plus 350. Again, notice minus 25x minus 25x. A positive 350, a positive 350. This is a discrete thing because you count rooms, and it's linear because we are subtracting. So when we graph it, 0 and 350 is our first point on the table. Then we have 1 and 325, and then we got 2 and 300, and then we got 3 and 275, and it's straight. We don't connect the dots, so we're good. Then it says how many rooms without elves after 10 hours. So again, you can plug it in, or you can fill out your table. And so this leaves us with 250, 225, 200, 175, 150, 125, 100. So the answer is 100. Now, if you're going to plug it in like I would have, because I'm a super nerd, again, I'm going to use this equation, but now instead of an x, I'm going to use 10. So when I write this, I got y equals negative 25 times 10 plus 350. So that gives me y equals negative 250 plus 350, which again is going to be 100. So see how these give me the same answer? So both are good, whatever way you like. All right, that's the end of the video. We're going to play a game for tomorrow's review, and I'll see you guys next time.